Good evening to all. Myself, Arun Kumar. I'm going to talk about state variable analysis. So far, we have discussed about how the state variable has been implemented in a control system for both the root locus and how the stability factor has been improved in the control systems. Now, this video we are going to see how the state variable has been performed in control systems, especially for state space representations. This state variable analysis has been analyzed and their performance has been implemented in the control systems. So state space representation in this state space, all the variables has assigned by x or y values. So based on the x or y values, we have to frame one matrix, and from the matrix we have to identify how much variables are present and how the values are denoted. So let's see how the values has been assigned and framed by using the state variable analysis. So the state of the system can be represented as a state vector when the space within a space. So the state variables are denoted by as input and output variables. Based on the input and output, we have to calculate the concerned matrix of the control systems. And next one is system. So based on the system, we have to initiate the input values. The input values are denoted as u and the output values denoted as y. So in between the input and output, we have to calculate the control systems. So in the system, we have to identify and frame the matrix by using this system. So the system can be calculated by x values. X means the system function with respect to the variables. So next one is the system frame of the control system. So here the matrix can be framed by the each and every value present in the system of the variables. So in this case, the values are assigned by x1, x2, x3, and their state variables has been denoted in this box a1, a2. Like that, all the values are denoted in this column. Next one is x1, x2, x3 because it's a differentiation of the concerned state equation x1 dot, x2 dot, x3 dot. Like that, we have to frame. So in this variables are present in this x1, x2, x3, the concerned factor which are going to define the state variables. And next one is input values. Input values can be calculated by using u1 and u2. Then the corresponding values of the x1, x2, x3. So like that, the system can be framed by using the matrix. So next one is, for example, if you are taking open or closed loop circuits, the values are assigned and their matrix by using the following method. First one is V1, V2 of T. The V1 and V2 can be denoted as X1 and X2. And then corresponding equation, we have to follow the matrix. So in this V1 minus V2 divided by R plus C into dv by, because it's the system which must process the value of the concerned voltage, so that we can take C into dv by dt equal to 0. And next one is V2 minus V1, V2 minus V1 divided by R plus V2 by R plus V2 by R plus C into dv by dt equal to V of t by R. So after assigning all the variables and their matrix, we have to calculate the concern factor, because in matrix itself we have to know about x1 and x2 values. We have to find the value of x1 and x2. So in this we have to place the variables by using the above methods. X1, x2 is next, the concern value of x1 is 1 by rc, and then the x2 is 1 by rc minus 2 by rc. Then if the value is present in the u, then you can place the value in the column 1 by rc into u. And if the doesn't have any value present in the matrix, so that you can place 0. So like that, all the values has been assigned in the matrix format. Then the constant output value has framed by using y equal to 1 0 x1 x2, because only the x value is present, x1 is present, so that I can choose 1 in the box. So if you are cross multiplying each other, we will get x1 value in the 1. So the remaining value will be 0. So if we don't get any value from x2, the y equal to x1. So like that, all the values are calculated by using this state equation. Thank you.